Welcome to tonight's video, the first one of the year for Math Analysis Calculus Honors on Unit 1, Part 1, Sequence and Series. First of all, we'll define what is a sequence. And a sequence is a set of real numbers in a specific order. So for example, and there's examples here too, 1, 2, 3, 4, and so on. That is a sequence in a specific order. Each number in a sequence is a term of the sequence. So if we look at this, for example here, there's some sequences and we have to fill in the blank. For example, 9, 14, 19, 24. If you notice, you're adding 5 each time. Right, so the next term, we add 5 to get 29, the next one 34, the next one 39. So if we look at this and I say, what is the third term of sequence B? Third term is 19. So that's what B sub 3 means, the third term of the B sequence. So if we're talking about the sequence C, 2, 6, 18, 54, well, notice now you're multiplying by 3 to go from term to term. So 54 times 3 is 162. 162 times 3 is 486. And then it's 1,458. And then for the next one, if you notice 5, 6, 11, 17, 28, 45, that one's a little different. But notice if I add 5 plus 6, I get 11. 6 plus 11 gives me 17. 11 and 17 gives me 28. 17 and 28, 45. 28 and 45 gives me 73. 45 and 73 gives me 118. And 73 and 118 gives me 191. So that's how I find those ones. So this one, it's basically the sum of the previous two terms. So to write a sequence, there are two ways to do it. The first way is recursively, and that is where basically that means defining the next term as in terms of the previous one. So basically, as it says, describes a rule that can be followed to obtain a term using the previous term or terms. And it has to be identical for all terms in the sequence, meaning it can't just be for one term, but then the next one's different. So for example, if you look at B sub n here, scroll up, and I make a recursive rule. Well, first of all, in a recursive formula, I need to give you the first term. In this case, B sub 1 is 9. And then I also now need to find the next term. I would take the previous one, that's B sub n. So B sub n plus 1 is the next term. B sub n would be the previous one. And I would add 5. So that is a recursive formula or definition for B. For C, C sub 1 is 2. And I would say the formula is that the next term is equal to the previous one times 3. So I go 3 C sub n. And for the last one, now I have to use the previous 2. So D sub 1 is 5, D sub 2 is 6, and I would say that D sub n plus 2 is equal to D sub n plus 1 plus D sub n. So it's the next term is equal to the sum of the previous two terms. And that is how you write a recursive formula for them. You're used to probably seeing the explicit definition, which describes a rule that can be followed to find any term in a sequence. For example, a sub n equals 5n plus 10. All you need to know is the number of term that you are trying to find. So the 1,000th term, you just put 1,000 in. So now let's look at some examples. So determine a recursive and explicit definition for b sub n here. Well, first, if you notice, you add 3, 5, 7, 9, 11. So it keeps going up by 2, but it's not the same number. So one thing we'll talk about is when this happens, where you're adding a consistent increase in the sum, like adding 3, 5, 7, 9, 11, where it goes up by 2 every time, it's going to be a quadratic. Now we have to figure out how, and we'll talk about the explicit first. So we have to figure out, well, how does it relate to the number of terms? So for example, b sub n is equal to, well, the first term it's 1, second term is 4, third term is 9. Well, if it's a quadratic, notice it's got to be n squared, then something. Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So here it has to be b sub n equals n squared. That's explicit. For recursive, I have to figure out how I go from one term to the next. And I can't just say add 3, 5, 7, 9. No, it has to be consistent. And since it is a consistent sum, it's probably going to be a quadratic. So I know the first term is 1. And now I look at it, it's probably a quadratic. And I look at it and I go, okay, what do I have to do to the first term and then to get to the next one? Well, 1 squared plus 3, but if I go 2 squared plus, or 4 squared plus 3, it doesn't give me 9. But what it ends up being is if I take the square root of b sub n, so if I take the square root of this term, 1, and add 1 to it, and then square it, I'll get the next one. So square root of 1 is 1, plus 1 is 2, 2 squared is 4. The square root of 4 is 2, plus 1 is 3, squared is 9. So notice that works for each one. And that's something you're just going to have to play with as you go along. For C, it's a little easier, because notice all I'm doing here is multiplying by 1/2 from term to term. So for the recursive definition, I'll say that C sub 1 is 10. And then I'll say that C sub n plus 1 is equal to 1/2 of C sub n, or C sub n over 2. Either way. For the explicit definition, it's a little trickier, but notice since you're multiplying by 1/2, 1/2 has to be part of the formula. All right, now how do you get from 1/2 to 10? Well, 20 times 1/2 is 10, but also if you start with 10 and you multiply 1/2 to the 0 power, you're going to get 10 times 1. And if you multiply 1/2 to the first power, 10 times 1/2 is 5. And if you multiply 1/2 to the second power, 1/4 times 10 is 5/2. So notice you just need the n minus 1 power there. So if it's the first term, you need 1/2 to the 0. If it's the second term, you need 1/2 to the 1. And third term, you need 1/2 to the 2, the second. So those are the, that's the explicit formula for that one. All right, so let's look at explicit formula for this sequence. And we talked about what happens when you add a consistent sum. It is a quadratic. So it'll be a quadratic as far as it's got to be an squared plus bn plus c. Now, some people can just look at it and determine what the answer is. But for those that need like a guide or a set way, we can use matrices, which you guys learned last year in Algebra 2 Trig, because first term is 2, right? So that means n equals 1. So that means that it was 2 is equal to a plus b plus c. If I put 1 in for the n's, I get that 2 equals a plus b plus c. The second term is 5. So I know that 5 is equal to 2 squared is 4, so 4a plus 2b plus c. And if I put 3, the third term is 10, so if I put 3 in for n, I get 9a plus 3b plus c. So now I have a system of equations. I can make a matrix, because remember last year you talked about ax equals b, and the A matrix here would be the terms. So you have 1a, 1b, 1c, so 1, 1, 1, 4, 2, 1, 9, 3, 1, and then the X matrix is just the variables a, b, and c, and then b is the solutions here, 2, 5, and 10. Now when you're doing these problems, this matrix will be the same no matter what, because it's based on the first, second, and third term. So there's no need to change that. The only thing that will change is the B matrix. That's the only thing that will change throughout the problems if you get a different sequence that you know is a quadratic. So remember, x is equal to A inverse B, because if you take the inverse of both sides, it's A inverse B. And remember with matrices, if I put the inverse on the left in one side, I have to put it on the left in the other, because the order does matter on which I multiply. So x is equal to A inverse B. So now this is where you use the calculator. So remember, with your calculator, you go second function matrix, and then you go to edit, and you're going to edit matrix A. Hit enter, and you're going to type in 3 by 3. I've already done it, but you can type it in again, 3 by 3, and then it'll tell you to what rows. So you just hit 1, enter, and then 1, enter again, and then again, and then 4, and then hit enter. So you go across, and 9, 3, and 1. So it's in there. All right, and then you quit out of that, and then go to matrix again, and then you want to do the B matrix. So you got to edit that, the B matrix, and you want to put 3 by 1, and then you're going to type in 2, 5, and 10. And just type those in, hit enter. Once you have it in, you quit out again, and then you go to matrix, and then you just hit A, and then the inverse key is right here, and then you go to matrix again, and then you go to B. So now you can multiply A inverse B, and it gives you 1, 0, 1. So that is the X matrix, which means that A is equal to 1, B is 0, C is 1, which means your quadratic is n squared plus 1. That is your explicit definition. All right. So that concludes our video for sequences. I will talk to you and see you in class. If you have any questions, please feel free to ask. Have a good evening.